Okay, so we took about 5 minutes to work on those problems by ourselves. Let's go ahead and look at them together. So number 1 says completely factor the following expression. 8x cubed minus 20x squared minus 12x. And that looks pretty familiar. We've been looking at factoring a couple times. What's the first thing that we look for when we're factoring?
GCF.
GCF. Do I have a GCF here?
4x.
All right, 4x. Jimmy, how did you know our GCF was 4x?
Well, if you divide 8 by 4, you get 2. Divide negative 20 by 4, you get negative 5. And same thing for negative 12.
Okay, so we saw that 4 went into each of our numbers here, our A, B, and C. And how did you know about the x?
All of them have an x.
All of them have an x. That's a great way to know that. So we have our GCF is 4x. And what do I do now that I know my GCF is my greatest common factor is 4x? What's my next step? What do I do with that information? Divide them all by the GCF. Exactly. So I'm going to divide each one of these. Let me move this one off to the side. Divide each one of these by 4x. And when I rewrite that, I have 4x. I have 8x cubed divided by 4x. My bad. Will give me 2x squared. 8x cubed divided by 4x. Negative 20x squared divided by 4x. Jimmy told us that we're going to get a negative 5. And one of those x's will cancel out. We have negative 12x divided by 4x. And we know that that'll give us negative 3. Sitting right here. All right, so I found my greatest common factor. I removed it from each of those values. What is my next step when I'm factoring my expression? The x in the box. All right. All right. Ibrahima, what do I need to put in my x?
Oh, fun things. Wait, what?
What do I put in my x box? At the top I put a times c? Okay. Negative 6. Good catch. Thank you, Soraya. Negative 5 on the bottom. So I'm looking for two numbers that when they're multiplied together are negative 6. When added together are negative 5. 6 and 1. Negative 6 and 1? Oh, how do we know? Okay. Belzy, what step did you take to get to negative 6 and 1? Did you just try a number? Did you guess and check? What was your process? You just knew? If I wasn't sure what numbers to put in, I would look at the top and I'd say, what numbers do I know go into 6? What factors do I have for 6? And I could try 1 and 6. And when I add those together, get negative 5. Okay. So I've found my two numbers that will be part of my factors. What's my next step? The box, the area model. Exactly. Jimmy, what do I put in that top left corner?
2x squared.
2x squared. And what else do I need? What other numbers and terms do I put in? -3. Absolutely. Where do I put -3? The bottom right. Thank you, Soraya. And I put -6x and 1. Does it matter which box? No. -6x and 1x. Okay, and then I'm looking for the greatest common factor of each row and column. So what is the greatest common factor of this top row? What's the greatest common factor? -3. Okay, so I'm looking at 2x squared and -6x. What do those two share? 2x squared and 6x? 2x, exactly, thank you. Because they both have a factor of 2, and they each have a factor of x. Now if I look at my bottom row, I have 1x and -3. 1x and -3. What is the greatest common factor? 1. It's just 1. Just a positive 1. Okay, then I can look at my left column. I have 2x squared and 1x. My greatest common factor. Yeah, it'd be just 1x. Okay, and my final one on that right column, I have -6x and -3. -3. Okay. So I'm going to write those factors in 2 sets of parentheses. I have my top values, x minus 3 and 2x plus 1. Are those my only factors? Don't I have to put 4x at the beginning? How do we know we have to put 4x at the beginning? Because that's my GCF. That's my greatest common factor. Has the word factor in it. I know that at the end will be one of my 3 factors. Okay. Number 2 says evaluate the following without a calculator. So we have A is log base 4 of 1. Log base 4 of 1. What is the problem? You want to draw a triangle? I like drawing a triangle for sure. Okay, so we have our triangle. What do I need to put in my triangle? Okay. How did Soraya know to put 4 at the bottom left and 1 at the other side? What's that?
4 is our base.
Because 4 is our base. And we're starting over here. Going all the way across. We have 4 and 1. So I'm looking for a number that when raised 4 to the something number equals 1. 0. How did we know it was 0? Because anything raised to the 0 power is 1. So 4 to the 0 equals 1. So I will write my answer. I evaluated log base 4 of 1, and that equals my exponent, equals 0. All right, part B says natural log of E. What does... Isn't that just 1? Okay, Belzy, will you walk me through your process?
The base of a natural log is E, and then I'm guessing E is the base, right?
Yeah. Okay, so Belzy remembered that natural log, ln, it tells us that we have a base of e. So if I wanted to rewrite that, I could say, okay, I have log base e of e. And if I drew my triangle, where would I write my e values? The bottom left would be one of them, and the bottom right. So I would be looking for a number that when e is raised to that number, it equals e. And that's what Belzy was saying. She found that the answer was 1. E raised to the power of 1 is itself. Right. What about log of 10,000? What's that? Would the base be 10? How did Soraya know that the base was 10? Because when there's no number that we see in the base, that's our common logarithm. That's our common logarithm, and that we know that's the same as saying we have a base of 10. So we can set up our triangle again. We put our base in our bottom left corner. We're looking for a number that when 1,000. Okay, Soraya, walk me through how you got 1,000. We just look at the zeros? Okay. So if I raised 10 to the 1,000th power, I would get 10 times 10 times 10 times 10 times 10 times 10, and on and on. How many zeros would that give me? Okay, so what? 4. Okay, so Soraya said she forgot to look at the exponent, but that's why we have our question mark up there. So Soraya, now I like 4. How did we get to 4? You just guessed? That's a good guess. All right. Is it right? Let's check. So if we did 10 to the first power, that would give us 10. Let me move this to the side. 10 to the first power would be 10. 10 to the second power would be 10 times 10 would be 100. 10 to the third power would be 3 zeros, 1,000. And 10 to the fourth power would give us those 4 zeros. So that is a wonderful guess. And it means that I can write my evaluation of that log as 4. And my last one, part D, says log base 2 of 1/8. It's going to be a negative. How did Soraya know that we're going to have a negative number? Because it's a fraction in our argument. Exactly. So we can rewrite it. We have our base in our left corner and 1/8. So we know that 2 raised to the some number, is going to be 1/8. And we see that our argument is a fraction, so we know we're going to have an exponent that'll flip our denominator and numerator. So what number would give us 1/8? 3. Negative 3. So we know that's going to be a negative because it's a fraction in the argument. And 2 raised to the third power, 2 cubed, would be 8. So we have this whole expression, log base 2 of 1/8 is negative 3. problem 3 says when solving a system of equations, you get -5 equals -5. What does this tell you about the solutions to the system? What does it tell you? Is -5 equals -5 a true statement? Is that true? Thumbs up if we think it's true. Yeah, -5 is the exact same as -5. So if I end up with -5 equals -5, what does that tell me about my system of equations? There's one. So is there a point? Do we have an x value and a y value? No, we don't see any variables there, so we know it's not going to be just one point. -5 equals -5. So if this is a true statement, and it means that our system of equations will always be true, no matter what point we pick, do we have lines that look different? If I am always going to pick, if for any x I pick, I get the same y, what would that look like on a graph? Any point I pick would give me the same y. If I picked 1, I would get this point, but if I picked 1 again, same point. Infinitely many solutions, because no matter which point I pick, that y will always be the same, and those lines would lie right on top of each other. They'd be the same line. Oops. So we would have infinitely many solutions. What questions do we have about those problems? Some of those look pretty familiar. We practiced them on the test yesterday.
All right. We are going to start Unit 10 today. Grab your books and turn to page 140. Well, you should have your books in front of you already. Page 144. In Unit 9, you guys learned about logs for the first time. A quick little hand raise. It doesn't have to be high, but if you found logs confusing. Were logs confusing? First time I ever saw logs, I was very confused by them. Usually the first introduction to something brand new, you spend a while, you're like, what is going on with this?
The introduction for logs for me was on the calculator, and I didn't know what they were.
Fair enough. Introduction to logs for Jimmy was a button on the calculator. Didn't know what it was. We're going to continue working with logs, and we're going to work on solving equations that have logs in them or that require the use of logs. Quick question. If I had log base 2 of 8. This is very similar to the bell work problems you guys were just doing. What is that equal to? What would that evaluate to?
1.
What'd you say? 1? I've got it written up on the board. Log base 2 of 8.
Oh.
What would that evaluate to? What'd you say? 3. Because why? Yeah. 2 raised to what power would give us 8? So I bring that up because this right here, when I write it as a log, this represents an exponent. The solution to it is an exponent. It's what power would I put on that base to get my argument. So we're going to use these ideas as we're solving logarithmic and exponential equations. To do that, the first thing we need to do is simplify which is the same thing as to isolate our log. Isolate means what? Get it alone. We're going to isolate our log. We're going to get it alone. And then this is the part that goes on the line. And then we will rewrite it as an exponential. We're going to simplify our logarithmic equation. We're going to isolate our log. We're going to get the log alone. When I say get the log alone, it's the word, the base, and the argument. All of those things have to go together. We can't split the argument or the base away from the log. They all stay connected and they move as one unit. So what happens if the base of the log and the base of the exponential function match? So down here I have a couple examples of that. If you see just log and no little number right down here, what is our base? 10. So I'm going to think about this the way we do with a triangle. Where would this 10 go?
Left bottom corner.
Left bottom corner. Where would my argument go?
Right bottom corner.
Right bottom corner. So what would the exponent be? 1. What's the base for the natural log? E. So even though I don't see it, there's a little e here. So same thing, I'm going to think about my triangle. E is my base. E is my argument. What would my exponent be? 1 again. So what happens when the base of the log and the argument match? Simplifies to 1. When the base of my log and the base of my exponential function match, those two things are going to simplify to be 1. All right, let's kick it up just a little bit. These last two right here, similar to the first two. What's the base right here? 10. I'm going to ask you to use the powers property that we learned when we were expanding. Where would I take this x if I was going to expand it? Put it in the front. So I would have x times common log of 10. But you guys just told me right back here that the common log of 10 simplifies to what? 1. So really I have x times 1. What's x times 1? 1x, or we could just write that as x. So this whole thing right here simplifies to x. What do you think that means about the last one? 2x minus 5. You're absolutely correct. Because again, I can use my powers property. I can bring that entire exponent down into the front as a multiplier. The natural log of e is going to simplify to be 1. It evaluates to 1. And so I'm multiplying that polynomial by 1. So far, so good? Cool. I've got some exponential expressions mixed in here. I want to look at number 1. What would this look like in its triangle form? What would go down here? The 10. Do I know what would go here? No. Do I know what would go here? How come it's not what? The 15. So the 15 is the argument for this, but what position is that all in? The log is part of the exponent this time. Good question, Pelsi. Yeah, so this is going to be log 15 up here. I'm not quite sure what it evaluates to. But if I take this and I write this bottom part in its log form, I would have log base 10 of, I don't know, equals, what did we say our exponent was? Log 15. And what's the base on this log over here? 10. So this matches. This matches. What do you guys think my question mark is? 15. That's the only way my two sides are equal. What do you think that means about number 2? Close. I'm going to write it like this. Think about that triangle. So I have e here. I have the natural log of 91 here. So if I write it in its log form, I would have the natural log of, I don't know, equals the natural log of 91. Because the natural log of 91 is my power. What'd you say? 91. So when I have something written as an exponential, and the base, like here on number 3, the base here is 5. And in my exponent, I have a log, and it has the same base. What happens to those two things? They basically cancel out. So how would number 3 evaluate? What'd you say? 1 what? 1x. Yes. 1x. This is working because logs and exponentials are inverses of each other. If I multiply something by 5 and then I turn around and I divide it by 5, those two operations cancel each other out, right? That's exactly what's happening here. I'm going to skip those last 3 down at the bottom so that we can get to some other types of examples. What do you notice on number 1? It's expanded. I have a log on the left-hand side. It's log base what? Log base 15. Do I have a log on the other side?
Yeah.
It is base what? 15. Well, if these two things match, what would have to be true about their arguments? They also have to match. If I want to say that two things match or two things are the same in math, what symbol do I put in between them? An equal sign, yes. So negative 2v is equal to 3v plus 1. Where would I go from here? Solve. What do I do to solve it? Subtract 3v from both sides. So what would that give me on the left? Negative 5v equals 1. And then what? Divide both sides by negative 5. So I get that v equals negative 1/5. Here's the thing. Do you guys remember when we were graphing logs and we got to pick our x's, we got to pick our exponents? or sorry, we got to pick our y's. My apologies. We got to pick our y's. Thank you. On the x's, we never, ever, 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 ever got back things that were negative. Anytime I take a value and I use it as an exponent, let's pretend my base is 2. If I did 2 to the power of -4, would I get a negative answer back? I'm going to get a fraction. Is there anything I could use as an exponent and get a negative answer back? No. So my argument can never be negative. My argument can never, ever, ever be negative. If I solve a problem and I follow all the rules from math and for algebra, I make sure if I do it to one side, I do it to the other, and I somehow end up with a solution that makes my argument negative, we have to throw it out. It's outside of our domain. It's not allowed. We say it's extraneous. If I take -1/5 and I put it in here for v, would this set of parentheses, because that's my whole argument, would that be a positive or a negative number? Positive. Why? 2 negatives make a positive. What about if I take this -1/5 and I put it over here for v, and I look at this whole set of parentheses here? I'm going to get a -3/5. Is that bigger or smaller than 1? Smaller than 1. So if I take something that's negative but smaller than 1, and I add 1 to it, would the full result be positive or negative? Positive. Positive. Let's look at number 2 real quick. What do you notice about those 2 logs on either side? Same base. So what does that mean about their 2 arguments? They're going to be the same. So 3x plus 7 equals 7x minus 3. What would I do with it from there? Minus 7x from both sides. So I get -4x plus 7 equals -3. What would I do then? Minus 7 from both sides. -4x equals -10. Last but not least, divide both sides by -4. Negative divided by a negative gives me a positive. X equals, what's 10 divided by 4? 2.5. Will that make either one of my arguments a negative number? No. All right, flip the page for me. I know we're getting close to the bell, but there's still a couple more examples that we need to talk about. Number 3, does this look like the last problem that we just did? No. What's different about it? I don't have a log on both sides, so I can't use the same trick. Can I think through this with a triangle? Yeah? What's the base on this log? 10. What's the exponent? 3. What's the argument? 5x minus 3. I'm going to rewrite this as an exponential. My base is 10. You said my exponent was what? 3. Equals my argument. What's my argument? 5x minus 3. Can we evaluate 10 to the 3rd power? Can we simplify that? It is 1,000. Absolutely correct. Equals 5x minus 3. Where to from here? Add 3 to both sides. Thank you, Ibrahim. 1003 equals 5x. Almost there. Divide both sides by 5. Not gonna lie, I'd need to grab my calculator for this. How much? 200.6. If I put this back into my log equation in the place of x, will my argument be a positive or a negative number? Positive. Then I can keep that answer. It is valid. Number 4. Number 4 reminds me of number 3. It's got something else going on, though. It has a -4 in the front. What operation is happening between the -4 and that log? Multiplication. Remember, I need to isolate this. Divide. Let's divide to get rid of that. I'm going to divide both sides by -4. So I'm going to have log base 8 of p minus 7 equals what? Equals 1. Now does it look more like number 3? So can I think through this with a triangle? What's my base? 8. What's my argument? P minus 7. What's the exponent? 1. So how do I rewrite this as an exponential? 8 to the power of 1 equals p minus 7. What is 8 to the first power? So this is just 8 equals p minus 7 plus 7 on both sides. So p is what? 15. If I put that answer for p back into my equation, will it make my argument a positive or a negative number? Positive. Then we are good with it. It is valid. All right. We are going to keep practicing. Thank you, ma'am. Solving exponential and logarithmic equations next week. I know next week is kind of weird. You guys will only be in the building for 3 days next week. Monday. Yeah, and I'll tell you where your new seat is, because we got new seats today. You guys will be in the building Monday, Wednesday, and Friday, unless you're a junior. If you're a junior, you will also be here on Thursday for SAT testing.